The M1 Abrams weighs over 73 tons. The German Leopard 2 weighs just 55 tons. That is an 18-ton difference between two tanks built to do the same job. Both carry the same Rheinmetall 120mm smoothbore cannon. Both were designed during the Cold War to stop a Soviet armored advance through Europe. Yet Germany built their tank almost 20 tons lighter. The question is why, and the answer reveals two completely different ideas about what a battle tank should be. If you subscribe to this channel, every video will break down the engineering behind the machines that shaped modern warfare. That way you never miss a single breakdown. Germany and the United States faced the same enemy in the 1970s. Soviet armor massed along the Eastern European border. NATO needed a new generation of main battle tanks. Both nations started from scratch. Both wanted speed, firepower, and survivability. But each country made very different choices about which one mattered most. The Americans chose raw protection above everything else. The M1 Abrams uses a composite armor system reinforced with depleted uranium mesh. This armor is some of the densest material ever fitted to a combat vehicle. Depleted uranium is 68% denser than lead. When layered into ceramic composite panels on the turret and hull front, it creates a shield that can absorb direct hits from most anti-tank rounds at combat range. During Operation Desert Storm, multiple Abrams tanks took frontal hits from Iraqi T-72 cannons and kept fighting. The trade-off for that protection is weight. At 73.6 tons in its M1A2 configuration, the Abrams is one of the heaviest tanks ever fielded by any nation. That mass limits where the tank can operate. Many European bridges have a weight rating below 70 tons. Soft ground and mud slow the Abrams to a crawl. Moving it across a continent requires heavy transport aircraft, ships, or reinforced railcars. The Germans took a different path with the Leopard 2. Krauss-Maffei engineers designed the tank with modular armor panels bolted to the turret and hull. These sections can be swapped in the field by a trained crew with basic tools. If a Leopard 2 takes a hit on its front armor plate, soldiers can unbolt the damaged module and replace it at a forward repair depot. There is no need to send the entire tank back to a factory. This makes the Leopard 2 far easier to maintain during a long, grinding fight across European soil. The base armor is lighter than the Abrams composite, but that modular design means Germany can upgrade protection as new threats appear. They have done exactly that across several variants, from the original 2A4 all the way up to the heavily armored 2A7 variant fielded today. Under the hull, the difference grows even larger. The M1 Abrams runs on a Honeywell AGT 500 gas turbine engine. This is essentially a jet engine mounted inside a tank. It produces 1,500 horsepower and gives the Abrams a top speed near 45 miles per hour on paved roads. Gas turbines are smooth, reliable, and deliver instant acceleration, but they drink fuel at a staggering rate. The Abrams consumes roughly 400 liters of fuel per 100 kilometers. Its operational road range sits around 426 kilometers before it needs to refuel. In combat, with constant acceleration and idle time, that range drops fast. Every Abrams column needs a long tail of fuel trucks behind it. The Leopard 2 runs a twin-turbocharged MTU MB 873 diesel engine. It also produces 1,500 horsepower from 12 cylinders, but diesel burns far more efficiently than jet fuel. The Leopard 2 consumes roughly 240 liters per 100 kilometers. That is about 40% less fuel than the Abrams for the same distance. The Leopard 2 can travel roughly 500 kilometers on a single fill. In a European war, where supply lines stretch across narrow roads and contested bridges, that fuel advantage matters. A tank that can fight longer without resupply keeps pressure on the enemy. Cost tells another part of the story. A single M1A2 Abrams costs between $6 and $8 million depending on the configuration. The Leopard 2 comes in around $6 million per unit. Both are expensive machines, but the Leopard 2 stretches a defense budget further. Germany has exported the Leopard 2 to over a dozen NATO allies. Nations like Poland, Greece, Turkey, and Canada all operate variants of the Leopard 2. That wide export base keeps production lines open and spare parts flowing. The Abrams, by contrast, is operated by fewer allied nations. Its turbine engine and depleted uranium armor create export restrictions that the diesel-powered Leopard 2 does not face. Battlefield philosophy separates these two tanks more than any single spec on the datasheet. The Abrams was built for American doctrine. The United States fights wars far from home, across oceans. It deploys heavy armor by ship and aircraft, establishes forward supply bases, and pushes forward with overwhelming logistics behind the front line. The Abrams fits that model perfectly. It is a fortress on tracks. It can absorb punishment and keep rolling because American supply chains are designed to feed it fuel, ammunition, and replacement parts across entire continents. Germany designed the Leopard 2 for a completely different fight. A war in Europe would happen on German soil. Roads, bridges, and rail networks would be contested or destroyed from day one. Fuel depots might be hit by missiles before the first tank rolled out of its motor pool. The Leopard 2 needed to move fast across broken terrain, cross bridges that might not hold 70 tons, and stay in the fight for days without guaranteed resupply. Every design choice reflects that reality. Lighter weight for faster movement. Better fuel economy for longer range. Modular armor that field crews can fix with wrenches instead of factories. Neither tank is better in absolute terms. The Abrams is the superior choice when logistics are strong and maximum armor protection is the priority. The Leopard 2 is the superior choice when mobility, range, and endurance define the mission. Two tanks sitting side by side on a military base would look like equals. Same cannon, same horsepower, same era, but underneath that surface, two nations built two very different answers to the same question. If this breakdown gave you something worth knowing, subscribe to Steel Doctrine. Every video here is built to respect your time and deliver real engineering detail on the machines that defend the free world.